Hello, my name is James, and welcome to my lesson on simultaneous equations. So the first question we've got to ask is, what are simultaneous equations? Like a lot of things in maths, we can immediately relate this back to graphs. So a lot of questions you'll get will be like y plus 2x equals 4 and y minus 3x equals 7. Solve these simultaneous equation pairs. So what these two things are is they're both equations for lines, if you were to plot them on a graph. And what these simultaneous equations are actually asking you to do is to find the point where they intersect. For example, if I was to try and draw these two lines on a graph, you would see that two lines will intersect at a single point. Our job is to find the coordinates that these two lines coincide at. Now, a lot of the time you could also get different types of equations such as curves or circles, but the idea still remains the same. The idea is that we want to try and find the coordinates which the two equations intersect at. Sometimes you'll get one answer, sometimes you can get two answers or even more. So let's start at the beginning with the easiest types of simultaneous equations, where you're trying to find the intersection between two different lines. So to start off, we're going to look at an example. We're going to go for 2y plus 3x equals 10 and y minus x equals 4. So there are two main methods that we use to solve simultaneous equations. The first one is known as substitution. The second one is known as cancellation. I personally prefer using substitution because it works for all types of simultaneous equation and not just two linear ones. However, normally the first one taught in school is cancellation because that one is generally thought of as being a bit easier. So let's go through the cancellation process first. The first step is to try and get a number in front of one of the letters to be the same as the other equation. So for example, here, in one of the equations we have 2y, and in the other equation we have y. So the best thing to do here would be to get them both to being 2y. How we do that is in the second equation, we multiply everything by 2. So this second equation turns into 2y minus 2x equals 8. And the best thing to do here is just to replace the original equation with that one. So now we have two equations, 2y plus 3x equals 10 and 2y minus 2x equals 8. Now we have to look at the signs in front of the numbers that we made the same. In this case, the numbers in front of y are positive 2 and positive 2. Positive 2 and positive 2. If the signs are the same, we subtract the two equations. If the signs are different, then we add the two equations. In this case, they are the same. So we are going to subtract the two equations. Let's look at this piece by piece. 2y minus 2y is going to give us 0, so we're not going to put anything. 3x take away negative 2x is going to give us 5x. And 10 take away 8 is going to give us 2. Now to get the x by itself, we just have to divide by 5, and that gives us x equals 2/5. Now, a lot of people lose quite a lot of marks here because they forget that when you answer a simultaneous equation question, you're trying to get the coordinates of a point where the two lines intersect. This means that you also have to get the y coordinate. You do this by putting the x back into one of the equations that we know. So in this case, let's put our x equals 2/5 answer back into that first equation, 2y plus 3x equals 10. When we put x into that, we get 2y plus 3 times 2/5 equals 10. Well, 3 times 2/5 is going to give us 6/5. So 2y plus 6/5 equals 10. Let me make a bit of room here. Let's take away the 6/5 from the other side. We get 2y equals 10 minus 6/5, which is going to be 2y equals 8 4/5, also known as 44/5. And now to get the y by itself, we divide by 2. So y equals 22/5. And that gives us the coordinate that these two lines are going to intersect at. 2/5 and 22/5. And that would be our answer. So now that we've looked at the cancellation method, let's have a little look at the substitution method. So substitution works by getting one of the equations to being a variable equals. So let's use the same example as before, 2y plus 3x equals 10 and y minus x equals 4. So let's get one of the equations to being y or x equals. In this case, the second equation looks a lot easier to make y equals. So if we add x to both sides, we get y equals 4 plus x. Now, if we take that y, we can replace the y in the other equation with what y is equal to, 4 plus x. So let's do that. 2 brackets 4 plus x plus 3x equals 10. Now, the first step for solving many equations is to multiply out brackets. So let's multiply out the brackets we just formed. 2 times 4 is 8, and 2 times x is 2x. So 8 plus 2x plus 3x equals 10. Now, let's simplify this. 8 plus 5x equals 10. Move the x onto the other side. 5x equals 2. And divide by 5. X is 2/5. Exactly like we had with the cancellation method. Now, if you were to put this into the original equation like we did before to find the y, you would get the same result, y equals 22/5. So this shows that both methods are equally valuable when solving simultaneous equations. However, the substitution method becomes particularly valuable whenever you have quadratic simultaneous equations. For example, if we had the two equations, y equals x plus 4 and y squared plus x squared equals 20. Well, in this case, you can't do the cancellation methods because we have some pesky squares in there. We have to use the substitution method. So let's replace the y in the second equation with what's equal to the y in the first. We know that y is x plus 4, so let's put that in. X plus 4 squared plus x squared equals 20. Now, if you multiply that out, you'll end up with a quadratic, which is fairly easily solvable, and you'll end up with two different answers. This is because that second equation is actually the equation of a circle. So, if you were to plot this out, you would see that lines generally intersect with circles twice. So you'll get two different answers. Let's have a look at some exam questions. There will be two exam questions coming up on your screen. Pause the video and have a go at them yourself and see if you can answer them. The first question is from the January 2015 paper, and it says x plus 2y equals 3 and x minus y equals 6. So here I think it would be easiest to use the cancellation method. So we have to try and make it so that the numbers in front of one of the letters are the same. In this case, the numbers in front of the x are both 1, which is nice and easy for us. Let's look at the signs. The signs in front of the x are both positive. So we use the same subtract rule. Okay? So let's subtract these two equations. x minus x is going to give us 0, so we don't pay anything. 2y minus negative y is going to give us 3y. 3 take away 6 is going to give us negative 3. Now we divide by the 3 to give us y by itself, giving us negative 1. But remember, this is not the full answer to the question. We want to find the set of coordinates where these two lines intersect. So we have to find the x-coordinate. We put the y back into the equation, I think the second one looks easiest, and see what it works out to be for x. X minus negative 1 equals 6. So x plus 1 equals 6, x equals 5. And that gives us our coordinates where these two lines intersect at 5 minus 1. The second question is a bit harder and comes from the January 2014 paper as the last question, so one of the hardest on the paper. As you can see here, we have some squares in the second equation, so we're not going to be able to use the cancellation method. We're going to have to use substitution. Luckily, the first equation is already in the form y equals, so we can put what y is equal to into the second equation immediately. That gives us x squared plus 3 minus 2x squared equals 26. Now, if we write down 3 minus 2x and square it by doing double brackets, that gives us 9 minus 12x plus 4x squared. Putting that into the equation and simplifying gives us 5x squared minus 12x plus 9 equals 26. As you can see, this is starting to look more and more like a quadratic. As you know, to solve quadratics, you have to make them equal to 0 first. So let's take that 26 and move it onto the left-hand side by subtracting it. If we subtract 26, we get 5x squared minus 12x minus 17 equals 0. Now, this is a bit of a nasty quadratic, so let's use the quadratic formula to solve it. Make a bit of space. The quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a, where a, b and c are your coefficients of x squared, x, and the number by itself at the end. When we put that in and throw that into our calculator, it spits out two different values when you use plus and minus. It gives us x equals negative 1 and x equals 17 over 5. But just like the other simultaneous equation questions, we are not done here. We need to find the y-coordinate that goes along with these x's. So if we pick the easiest of the equations in the question, y equals 3 minus 2x, and put in those x values, it gives us a y value for each of them. In the first case, y is 5. In the second, y equals negative 19 over 5. And that gives us two coordinates, which makes sense because we have a line intersecting a circle, which is going to happen at 2 places maximum. Thank you very much for listening, and I hope that you tune into our other videos.